Today, we're going to be talking about something that I love, higher order functions. This is why you should trust me, blah, blah, blah. I am Tim. I am a staff software engineer at CircleCI. We are hiring. If you guys want to come write enclosure or some fun JavaScript, hit me up. You can find me online there. I wouldn't, but if that's your thing, feel free. And I will be tweeting out the slides and some book recommendations at Cirska or Kurska, however you want to say that. Before I even begin, though, I feel like it's really important to make something clear. I am not starting a holy war here. OOP is not bad. Functional programming is not good, right? Like, you are not a bad developer if you use Java and use OOP. All I'm trying to say is that sometimes you have a screw and it's really hard to knock it in with a hammer, right? This is just a new tool to use if you think it's important, right? I'm not saying like tabs versus spaces where one's obviously right. There's a story that's kind of in line with the Tao of programming. If you all haven't read this book, I highly recommend it. Google Tao of Programming PDF and it's free. But the story goes, there's this sensei and their student are walking. And the student says to the sensei, hey, you've been teaching me this object-oriented thing, but I've heard about this functional stuff. Like, what is going on there? And the sensei thinks for a second and goes, you know, like a function is a poor man's class. A closure is a poor man's object. And the student goes, okay, I'll think on that. A couple days go by and the student comes back just running like, sensei, I get it. I see the light. You are totally correct. A function is a poor man's class. A closure is a poor man's object, right? And the sensei smacks the student upside the head and says, you fool. An object is a poor man's function. A class is a poor man's closure. And the student was enlightened. That doesn't mean anything. It's just a little fun story. There's some buzzwords like any good functional programming talk. We're not going to be talking about monoid or setoid or church lambda calculus. I would love to nerd out with you guys about that if that's your thing. But there are some words we have to know. Higher order function being one of them. If the whole talk's about that, what is it? And all it is any function that takes a function or any function that returns a function. I use the word function there, basically the whole word. So let's look at code. If you've ever done jQuery on and you've passed that method of function, or you've added an event listener and you've passed that method of function, you've interacted with the higher order function. Simply because you passed a function to that method is now higher order. Right? If you ever dealt with a promise and you've said .then or .catch and you've passed those methods of function, those methods are higher order functions. Nothing new, it's just some word that somebody made up and now it's a thing, right? The next two, I'm not smart enough to describe by themselves. To me, these two things are tightly interconnected, right? So scope and closure. Scope is this idea of what does my worker have access to? What can I say, hey, computer, console log X? If it can look at that value is in the scope of my worker, right? And closure is this idea of I can create new scopes. I can say, hey, this is a new world, this is a new scope, and what also happens is I carry on the scope I had at that time. A lot of words, let's look at code. So I have some value in my global scope or my module scope, right? A. I have this function called outer scope, and I have this function called inner scope. When I call outer scope and I reference value A, it's referencing some value. However, in inner scope, I say, hey, I'm going to create a new value. I'm going to create this value called A, and it's some other value. And when I call it, I don't print some value, I print some other value. Makes sense? The important thing to note, though, outer scope A doesn't have A in its first scope. So it has to ask its parent, hey parent, what's A? I don't know this. And the parent goes, oh, I do. Here. Inner scope A says, no, no, I've got A, I'm not going to ask anybody. But I can never touch value A inside of inner scope. From outside of that function, that value is inaccessible. I can never touch it. I can never see it. Only the worker inner scope has access to it. To put it another way, I can always go up in scope. I can always ask my parent or my grandparent or the global object. I can never go down. I can never say, hey, child, what is your scope? What values do you have? I can never go to my siblings, right? Outer scopes A will never, ever, 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 ever be inner scopes A. Except this idea of closure, right? So closure is this way to create scope with its accompanying scope. So I have this function called closure. It creates some value inside of its scope. But look at what it returns. It returns some function that will return to me the value A. So when I call closure, it returns to me that function. And because of this closure, because of this idea of carrying my parent's scope with me, I can get access to that A value. Right? So this getA function holds on to that const A. So now anytime I call getA, I still have A in my scope. That is all our talk's going to be over. Higher order functions, scope, and closure. That's it. And I wish we had months to spend. I love diving in. I love writing code, but we don't. I've got 30 more minutes. So we're going to pretend that we've created the next big unicorn app in the valley, right? We're getting a $50 billion evaluation. But before we even start, before we even create some code, we have to think, what are some of the rules we're going to follow? Right? Our worker, our computer doesn't give us any boundaries. It says, you tell me what you want me to do, I'm going to do it. But we as a team have to come up with like a paradigm or a framework or a methodology that we're going to follow, right? And if you went to school since '79, if you've done Angular or if you've done .NET, you've done enterprisey things. This was your Bible, basically, right? You are going to encapsulate data and the methods that manipulate that data into an object because it makes good sense. It's safer, it's more convenient for this to happen. So sure, people way smarter than me have said it. Let's build our app. As you can tell, this is definitely worth $50 billion. But let's pretend this is harder, right? Let's pretend that this domain is indicative of something you're working on. Here, it's just some method. So you do this, you write your tests, you ship it, everyone's happy, right? You've shipped version 1 of your app. Something happens, though. And it's the same thing that happens every single project I've done for 15 years, right? No matter what language, no matter what idea, no matter what platform, the moment I ship that to my boss, they come back and say, close but not close enough. They say, oh, that's great, but the market's changed. Our job as a developer isn't to write code. Our job as a developer is to change code. Luckily for us, our change is just addition onto our domain, right? We had this print names, now we're going to add this print ages. And this works. We can ship this, everyone's happy, but if this went into my code review, this is all I would be doing. Right? I would be spending my whole entire time looking at these two methods thinking, what's the only difference? I would not even be looking, are these correct? I would be looking for this one part. That's it. .age is the only thing that changes between this method and the one above it. So what is it that we're really trying to say in those two methods? If I'm only changing one word To me, that means I'm saying the same thing. And what we're saying is I want to iterate over my internal data structure. I want to iterate over my list. And for each item in that list, I want to do something, right? In print ages, I want to print their age. In print names, I want to print their names. But that's 2% of what I said. So how do we write that into our code? Well, we just tell our worker, hey, here is how I iterate. At some point in the future, I'll know what I want to do. Right, so I create this method for each teacher. It's the exact same iteration as it was both of those methods, except instead of me hard coding what I do during each iteration, I say, no. Somebody in the future is going to tell me. Someone in the future is going to pass me a function, and that's how I know what to do. So in print names, I'm going to iterate over my teachers list and print each teacher's names. In print ages, I'm going to iterate over my teachers list and print their age. That's kind of cool, I guess, but like, why? Right? And to me, one of the bigger things is we get this separation. No longer does each method have to know how to iterate. No longer does each method have to understand my data. Now I can say, hey, no, here's this forEach thing. That understands my data. This print ages, this print names thing, that understands a data point, one small piece of it. And when I separate these two things, when I separate the what from the how, I can test this. Right now I can say, okay, forEach, you're going to do your job correctly. Print names, you're going to call this method correctly. But the coolest thing, and I kind of pointed at it, is I've separated the what from the how. What I want to do is call some function for each teacher. That's what I want to do. How I do it, I don't care. As the developer, I don't care how I forEach over my teachers. I care that during each iteration, here's what I want to do, right? That's cool, I guess, right? We ship it, everyone's happy. But something else happens. Once again, we have to change our code. We have new requirements, and this time, it's not just extending our domain, it's creating a whole new domain, right? This whole new students thing. And what happens is you get your JIRA ticket, you crack your knuckles, and you dive in, and you're like, wait a second. Version 1 had this. Version 1 of our software that we spent months building, I could print the names of something. Yeah, it was a different domain. Yeah, it was a different idea. But they're the same thing, really. To me, as a developer, I know this. But when we try to ask our computer for that information, when we try to get just print names, we run into what Joe Armstrong's talking about here, right? Joe Armstrong says, not me, that object-oriented lacks reusability. It has nothing to do with how hard you try. It has nothing to do with how good or bad you are. The fact that you code in object-oriented alone means you cannot reuse your code. He says when you try to get just a banana, just print names, when you try to grab that, it's associated with all this implicitness, all this implicit environment that you coded into that function. What do I mean by implicit state? Where's the implicitness in this method? This, exactly. Not this as in the whole picture, the word this. Anytime you see the word this, you should be thinking to yourselves, oh no, right? Because what you're telling your worker, what you're doing is saying, I know every permutation this object will ever go through. I, as this fallible human, know every single way this will ever look. What do I mean by that? Let's say we had some class that has some data and it does something with this. That works. Basically what we've already done. I can ship this, I can test this. I know this module, this class works. But what happens when this guy shows up? Maybe it's a junior dev. Maybe it's somebody who's new in the company. Maybe it's you 5 days after you write that code, right? And you have a bug, and that bug is some view way over here needs some value to be null, right? So in some module, you instantiate this class, and it works on that page. In some other module, totally removed from module A declaration, you extend it. You're not inheriting, you're doing mix-ins. You're doing OOP the correct way there. But because for some view data in Angular, I needed that to be null, right? And I move on, everything works, all my tests still pass. Some of you are seeing where this is going. What happens here? If I call these 3 lines in this order, what happens? Pardon? Gets nullified. And now I get this weird cryptic error. It's yelling about module A, but module A passes all my tests. Module A is not wrong. What happens if this is miles apart in code, right? Module A is some screen on your web app. And your user keeps this web app or this server open for days. And on Monday, they cause line 1 to be called. On Wednesday, they cause line 2 to be called. On Friday, they cause line 3 to be called, and you get a Graylog error saying A is null. Where? The only way you would know it's module B.set data is if you, in your head, kept track of every permutation this place in memory is, right? These aren't things. These aren't users. These are registers in our computer. And if you can keep track of every single time you touch that registry, cool, go for it. If you can't, you're going to get this bug and pull your hair out. I'm bald now. How do we fix it though, right? If I'm going to complain about this, I better have a solution, right? And I like to think of it as this Lego architecture thing, right? I'm mixing and matching. I don't care how this box is made. I don't care if it's a student or a user. I don't care about anything. All I care about is that I have a piece that's got 8 pieces and some holes in it. I don't care what goes on in the middle. No matter where I use that blue piece, it's going to fit. I can put it on top and bottom. I can reuse these places. What does that look like? We just remove the implicitness. We make what was once implicit explicit. So here, at the very top, instead of me saying this dot something, I say, hey, I'm going to pass it to you. So instead of list pointing at the same place in memory for the lifetime of this function, it points at the argument I pass in. Right? So now, in this domain, in this world, I can use forEach. In this other domain, in this other world, I can use forEach. ForEach is no longer tied to an instantiation of an object. It's tied to an array, any array, right? And that's super cool, I guess. But then we run into this problem, which once again, that's the only thing that changes. This is prettier. It's using functional stuff. It's fun, right? What's another way that we could say this? What is it that we're really trying to do with student.age or student.name? One way to think about it is given a key, given some property, and given the object, I'm going to return to you the value of that property, right? So when I call prop name student, I want to get the name property off the student object. When I call prop age student, I want to get the age property from the student object. That looks better, I guess, but like that's really not what I wanted to say, right? This isn't cleaner. What I really want to do is I want to name that. I want to say, okay. I know the key. I know the property I want. I don't know the object yet, though. So just like with forEach, I knew I wanted to grab the name. I don't know how I iterate, though. We could rewrite prop as that. So now, instead of me taking the key and the object at the same time, I use closure, I use scope to say, no, 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 no. I know my key right now. I know I want the name. I know I want the age. I don't know what object that is yet. I don't know what memory location that is held at yet. So when I call prop, I give it some key value, right? So I say prop name. That returns to me some function. I'm going to call it getName, so I can be really descriptive on what this does, right? So what happens when I pass in this student to getName, that matches the object at the very top. And because of closure, I have name, the string, as key. At the very end, I can say object.key, or object.name, right? Same thing with age. This function prop that I'm returning is the function object yield object key. It just so happens to, in its scope, in its closure, hidden from us, that string age. Okay? What if something else happens, though? What if I don't just want to iterate over and do something? Right? What if I want to create something? What if I want to take my list and create some new list? What would that look like? Using forEach, we could do something like this, right? I create some list. I'm going to iterate over my list and push onto it this transformation, right? So I'm going to iterate over some list. I'm going to grab their age, push it to this list, and return to the caller. What's another way we could write that, though? Maybe, just maybe, we could come up with this idea of mapping a domain to a range. Given a list of things, I want to map them by some transformation function. So I have this function called map, hard to read, I apologize. It takes in a function and a list. It's going to use the exact same code we had before. It's the exact same code, except I don't know what function I'm going to call yet. That's the only thing that changes between the previous implementation of this one. Instead of me saying, I know what I'm going to do right now, I'm going to let you pass that in. So when I create my names list, I want to map over getting the name of this list. And that function will return a new list, right? It will forEach over the passed in list, applying some transformation function. Similarly to how we did props, similarly to how we said, I know half of the information now, I'm going to know half later. We can write map like that. So now I can say, hey, I know how I want to transform each item. I don't know what list they're going to be in yet, though. I know I want to get their names. I don't know whose names I want yet. I don't know what list that is. So I can create this function called map. It's given a function. It's going to return a function. Just like with prop, I can take some information in, hold it in my closure, and return some function. Using that, now I get to say something really interesting. I'm passing around the idea of getting names. I'm passing around the idea of iterating over a data structure and transforming each item. And now, instead of this idea being tied to my data structure, I'm free to apply this idea in any domain I want. Any place I need to get their names, I have a new Lego piece, right? By gluing map and prop together, by gluing a red and a blue one together, I have this purple piece, this get names piece. that I can now pass around as if it was a value. But what if we didn't want to create a new list? What if instead of iterating over my list and creating a new one, I wanted to instead take my list and make it into a single value? It could be an array, it could be a number, it could be a string, it could be an object, it could be anything, right? Specifically, specifically, I want to take my students list, I want to transform it into the max age and the min age. Right? I want to set some max as a really low number, and then iterate over my students list, and for each student's age, and given the last max, set that mutating max value. Once you're done, return the last known max. Right? Similarly with min, I'm going to set min to be whatever the minimum is between that. Once I've done that all the time, I'll return the value. What's another way we could say this? Just like with forEach, what's another way we could come up with a way to generalize this idea? I want to reduce a list into a single value by applying some function given the last value and the current value. That's wordy, so let's look at the code. Wow, they really cut that off. That's fine. Reduce, way at the top. You can't see it, but it's going to take a function, some start value, thank you, sir, and a list. And just like before, just like with this code, I wrap this thing in some function. I wrap that for each and the updating of the mutable value in some function. Right? So now, max age is the reduction of my students by that function. Min age is the reduction of my students by this function. Let's walk through what's going to happen here, right? Let's do min age since it's close to me. Let's say this dot students, it was a list of objects, all with an age key, 10, 11, 12. Let's walk through what happens here, right? During our first iteration, what is min? Pardon? 100, perfect. Student, some object with age 10, right? This is going to return, what's the min of 110? It's going to return 10. Our next iteration, what's min? 10, perfect. Student, something, we keep on doing that, taking the last return value and the current iteration value. That's cool. I mean, it's kind of confusing. Like, I kind of have to know what's happening here, but what's the benefit of this reduce function? The benefit is it's not tied to anything. Sure, we use this to iterate over some list of objects and return some value, but how could I use it to tie these two things together? How could I use this idea of reducing a list of values into a single value to take two functions and compose them into a single value, or pipe them together? How could I glue these two Lego pieces together? In functional programming, there's this idea called pipe. And what pipe takes is 0 to many functions. That's what ... fnns means, right? 0 to many. Once you pass it those functions, it's going to return to you a function. That function is expecting some start value, some initial value, and it's going to reduce your functions by calling the next item with your last state. Right? So here, get uppercase names. I'm going to create a new function called getUpperName. What getUpperName is that function start yields. That's what getUpperName is. When I map getUpperName, let's walk through what happens, right? I have some list, Bob. So some list with some name called Bob. It gets passed to getUpperName, That's that start value. And we're going to add that. So what happens is prop name gets given this object name.bob. That returns Bob, some string. That value gets fed to upper using the pipe function up there. So I could have hundreds of thousands of functions. Your stack would get huge and blow, but you could, right? You can glue all these small pieces together and become uber descriptive. I, as the next user, don't care what this does if it works. If get upper name does its job, I can pass it any value. It's going to get the upper name. If I do care, I can create breakpoints in this chain. I can say tap, console log, whatever prop name gives me. Is that one right? Yeah, cool. That block's fine. Let me move down. Instead of us guessing what's throwing an error, we have small composable Lego pieces. Something that you've noticed, though, is we started our code very similarly to this, right? I have some function, I have the arguments, let me write it. But then we ran into this thing of, I know some options now, I don't know all of them. So what if there was a way that instead of me as the developer having to write the code one way or the other, I could have my worker decide which way to use it. Put it another way, instead of me saying, I'm going to give you one at a time, I could say, I'll give you 1, 0, or 2. I'll give you one argument function, I'll give you 2 arguments, function and list, or I'll give you nothing, whatever, right? And until I give you all of my arguments, return to me a function. So with map, I have to give it all of its arguments one by one, and until I do, it's going to return to me a function, right? I give it one argument, it returns to me a function. I give it the next one, it does its job. What if there was a way we could write all of our code like this, but interact with it as if it was written like the above? What would that look like? And this function curry uses everything we've learned. Higher order functions, scope, closures, in order for me to be able to use prop or map however I want. Right? So this function curry is going to take some function in. It's going to return some function. That function that it returns gives you as many arguments as you want. As you call the function that returns, if you give it enough arguments, it's going to call the underlying value, right? So with map, if I give that map function 2 arguments, it will call that inner block. Prop, if I give this function 2 arguments, the length of that function, it's going to call the function I gave it. If not, it's going to return a function saying, hey, I still don't have enough. I know how many I need. I don't have enough. My arg's length is not greater than or equal to my function's length. Caveat, this does not work with default arguments. Sorry, Charlie. So knowing that, I can create this function called prop name and just call it 1 billion times. It keeps on giving me a function back until I give it enough arguments. Map. I give it 1 argument and just keep on calling it. It's like, hey man, you haven't given me enough yet. Keep on keeping on. Finally, I give it the last one. It goes, oh cool, I can finally do my job, right? Like I said, I am not dogging on anyone's idea of what good code is. I'm not trying to say that you're bad. But man, oh man, all a computer can do is transform. Our computer does not know what a user is. Our computer understands given a 0 and given a 1 through this NOR gate. I'm going to give you a 0 or 1 or whatever you smart people know. Right? It's not a user. It's not even a function. It's I'm going to send electrical impulses, and eventually they're going to cause other ones. And if we can code in this idea of, hey, computer, I know you don't know what a class is, but you understand transformations. You understand given a value, produce a value. How much more productive could we be if we spoke to the computer in the language the computer understood? Is a class a poor man's object or a poor man's function? Is this closure this poor man's object? It doesn't matter. Your users do not care if you use OOP. Your users don't care if you're using cloud native Atlas or whatever the hip thing is now, right? Your users care, can you get this done? Can you fix the bug that I put on your Zendesk? All your bosses care about is how much money we're making in the market. And the only way we make money in the market through over and overly changing your code. So if you want to use OOP, please do. If you run into this hard problem of everything's coupled together and one change over here causes this page to fail, and now this one-line change is taking your team 3 weeks to do, maybe stop hammering the nail, or maybe stop hammering the screw. That's it. I would love to nerd it out some more.